Are you ready to venture into the deep mysteries of the universe? Join us as we uncover the newly discovered class of black holes, intermediate black holes. Learn about their formation, size, and potential implications on our understanding of the cosmos. Be part of this revolution and don't forget to like, share and subscribe. This helps us bring weekly content for you. Stellar black holes are our first stop. Born from the cataclysmic death of a massive star, they have a mass up to 20 times greater than our Sun. When such a star exhausts its nuclear fuel, it can't withstand its own gravity and collapses, exploding in a supernova. The remnant core, if sufficient in mass, collapses to form a black hole. For instance, the black hole Cygnus X1, one of the strongest X-ray sources seen from Earth, is a stellar black hole roughly 7,200 light-years away, with about 15 times the mass of our Sun. At the opposite end of the scale, we have supermassive black holes. These beasts, with millions or billions of times the mass of our Sun, are thought to reside at the centers of most galaxies. Sagittarius A star, the supermassive black hole at the center of our Milky Way, is over 4 million times the mass of our Sun, yet it's crammed into a space no larger than our solar system. But what bridges the gap between these two extremes? Intermediate black holes, which have masses ranging from 100 to several 100,000 times that of our Sun. They are incredibly hard to spot due to their smaller event horizons and lower activity levels. For a long time, these middleweight champions of the cosmos remained theoretical. However, recent evidence, particularly from the Gravitational Wave Observatory LIGO, has strengthened their existence. Before we move forward in this fascinating topic, please like and subscribe to support the channel, so we can bring fresh weekly content for you. One of the strong candidates for an intermediate black hole is HLX1. Located in the galaxy ESO 243-49, it's approximately 290 million light-years from Earth and is estimated to have a mass of about 20,000 suns. Its discovery has helped us understand how black holes might grow from stellar to supermassive sizes, shedding light on the evolution of galaxies. We've always wondered how supermassive black holes formed so early in the universe's history. One theory is that they grew from stellar black holes by accumulating mass from their surroundings, or by merging with other black holes. However, these processes take time, more time than what was available in the early universe. But with the discovery of intermediate black holes, we now have another possible path. Intermediate black holes could serve as seeds, rapidly attracting mass and forming supermassive black holes in a relatively shorter time span. This discovery also has significant implications for gravitational wave research. Gravitational waves are ripples in the fabric of spacetime caused by the acceleration of massive objects. The detection of these waves from the merger of intermediate black holes could provide more insights into the population and properties of these elusive objects. Scientists all around the globe are actively hunting for more of these elusive cosmic beasts. Advanced technologies, like the upcoming Laser Interferometer Space Antenna, LISA, will be a game changer, enabling us to detect gravitational waves from the mergers of intermediate black holes. And as we uncover more about these cosmic intermediaries, we are also answering fundamental questions about our universe. It's a classic case of how the exploration of the cosmos not only expands our knowledge of the universe but also our understanding of the laws of physics. We have embarked on a new era of astronomical discovery, and the future looks brighter than ever. We hope you've enjoyed this journey into the world of intermediate black holes. There is always more to explore, more to learn, and more to understand. So, if you're as excited as we are about these discoveries and what lies ahead, do subscribe to our channel and join us in our next cosmic adventure.